Let's talk about resource-based constraint delegation. Specifically, where you can find this in your environment, what does that mean, and how can red teamers exploit this to gain domain-level privileges on your network. Resource-based constraint delegation is a Windows feature that lets a resource control which accounts can request its Kerberos tickets. Once the delegation is set, the delegated object performs an SVU to self to first obtain a forwardable service ticket. That ticket is then used to perform an SVU to proxy, which then sets it for the target's resources impersonating another user within the domain. Once that proxy is complete, the attacker then has a resource for that target's device, allowing them access to those resources. Most importantly, we cannot perform the SVU to proxy unless a valid SPN is set, or service principal name. Now, there are a few prerequisites you need to have before you can actually perform this attack. Number one is you need to have control over an SPN. Number two is you have to have an object that allows you to write on the MSDS allowed to act on behalf of attribute. Now, there's several different attributes that actually allow you to do this, which is write DACL, write property, generic all, or even just all extended write. Anything that allows you to write to that specific MSDS allowed to act on behalf of attribute, which allows you to facilitate this attack. Now, additionally, there are other prerequisites for this. If you want to perform the impersonation and you can't use a local administrator due to having the local administrator marked as not sensitive, or sensitive and cannot be delegated, an alternative would be to find a service account that is highly privileged but is not marked as sensitive and cannot be delegated. This could be your loophole to then allowing you to put that as the user within the ticket request to obtain that resource. Now let's go over how we can do this attack using Linux with... Alright, so full disclosure, what we're going over here is a lab that I have built myself, and so this is a recording of how I went through these steps. So we're just going to go through here this video on how I exploited resource-based constraint delegation, and ultimately just 3 steps. So let's go through it. So first we're starting here with Bloodhound Python. We're specifying our domain level user, specifying the password and the domain that we want to target. Okay, so let's start. Okay, and all we're doing first here is just enumerating the network, and we're looking to get this JSON output and plug it into our Bloodhound so that we can map the network. Okay, and now we open up our Bloodhound Community Edition and we're dragging the JSON files that we just got from our bloodhound.python, and we're going to go ahead and upload that to Bloodhound for processing. Alright, and what we're looking at now is a map of what we found on the network. Ultimately, all I did here was just add shortest path to users. So there's nothing else that I really did. So I selected the users owned, and then I went to the queries and I found shortest path to user objects. So this is the output that is showed to us here. And it looks like we have generic all on our server, and we have write account restrictions to our workstation, to a workstation 1 that for some reason has generic write to a domain controller. So that's our scenario here. So in order to exploit this, we're going to first abuse generic all onto our server, and then we're going to use that compromised account to set the delegation to workstation 1, and then request the resources on that device for the target device on workstation 1. All right, so we're starting off here with in-packet RBCD. We're setting the delegation to workstation 1 from the server 1 that we control, because if we go back to our map here, the user Carol has the ability to write those account restrictions to workstation 1. So we don't actually have to log in as the server 1 quite just yet. So we're using Carol's credentials to then set the delegation. And first we're checking to verify that there's nothing pre-existing there, so we're not actually destroying or compromising any existing production causes for them. So we just set the write action here, and we're writing the ability to delegate, which we just did here. And we can see now that server 1 is now able to impersonate users on workstation 1 via SVU to proxy. And like we mentioned earlier, we requested a silver ticket for ourselves first, then making it affordable, and then we're using our ability to write with our own SPNs to abuse this SVU to proxy to then allow us to act on behalf of others for that resource. All right, our next step here is to request a SIVS ticket for the service we want, or to request a silver ticket for the resource we want, and specifying the user to impersonate across our domain. The command we're going to use is inpacket-get or for silver ticket, requesting a SIVS ticket using specifying the impersonation for John, and then we're specifying the credentials for the server that we want. And the way we got that credentials for that server 1 is by simply just doing impact or secret stump on server 1. But we could also go about using a Kerberos ticket as well if we wanted to go down that route. But just quick and easy, impact or secret stump, or we can just run mimikatz in the object if we have that kind of ability to. But I like to stick strictly remote, so if we were able to. So in this instance, I got the AES key, logged in as the user or as the computer account server 1, and then performed this request here. And as you can see, the output here is a ticket for the user John, which is a privileged account that is not marked as sensitive. It cannot be delegated, and it is a sys ticket for workstation 1, allowing us SMB access to the resources on the device. And now we are just configuring the variables needed to log in with the sys ticket, which is export into KRB5 CC name, specifying the C cache file we want to use, and we're just verifying real quick to see if the ticket is valid, which is what that klist command is for. And now we just run impact and secret stump, and we can see we just got all the clear text credentials for the workstation as well as any other Kerberos keys. And that pretty much means we have at least system level access on that target device. So this just moved us up onto the next phase for our domain escalation path. I'm also going to do a quick demonstration how we can do this using Windows. Kind of a similar situation, but in this case, we're going to go ahead and get access to our box first, to our first server, and then we're going to steal a session of a known user that has the ability to write through all extended writes to the other object. And we're going to use that ability, or to steal their session, to then abuse their domain privileges, to set the delegation, to then perform resource-based constraint delegation, to then pivot our way into the domain. Now let's go through the Windows variation of this exploit. What would it look like with just a standard beacon on the device itself, and how you'd abuse resource-based constraint delegation to go about this process. So we first start off by just listing different processes because we have system level access in a high integrity system with this box. We used the Elevate kit because we abused the generic all and got access to that device as a full system. So we just used the Elevate kit to then elevate ourselves into a higher integrity process, and now we're listing the different processes within the workstation or the server. So we're looking through the different processes here, and we see that we have a user John. And looking in Bloodhound, we found that he was a privileged user. Let's steal John's token now. And once we see that we successfully stole John's token, we're going to now use his privileges to run sharp RBCD to then set the delegations we need. So the next thing we're going to do here is use Rubus to triage the different Kerberos tickets on disk, and we're looking for the KRB TGT ticket for our workstation. So we see we found one here, and then we go ahead and then dump the ticket using Rubus. And then the next thing we do is just request the specific ticket that we want with the impersonation set. So we have the SIFS ticket for, in this case, the domain controller, and then we're impersonating the user John. Because we know, again, John has a privileged account that has that ability to request those resources. And lastly, we create a session here using the create net only, and then we inject the newly created ticket into that session, and then we steal the token for that session, and then once we finally steal that session, that token for that session, we can then LS into the domain controller. Now for the defenders, how can you protect against this? I would recommend tracking any kind of object writing to the MSDS allowed to be hacked on behalf of attribute. If anything attempts to write to it, I would definitely take another glance at that and see what is doing it and what is being written to that. For instance, if a domain user is just somehow writing to this computer object, you might want to take another glance at that. Versus if you have an administrator who's actually doing their own function, setting that delegation, then it might be something that's not too troubling. But I would definitely recommend observing who is writing to this attribute and why. Another question you might be thinking is this still relevant in 2025? And the answer is yes, this is still definitely relevant due to the fact of it just takes one accidental misconfiguration within your DACL to allow this exploit to occur, right? So although if you traditionally look through how red teamers should be exploiting this, they usually recommend adding a computer to the network. So they say to observe the machine account quota, see if you can write a computer, or create your own computer object, and then use that new computer object to create a password, and then to abuse the same steps to perform this attack. But realistically, you're not going to have that ability to just create your own computer and do that within a sophisticated environment. It doesn't work that way. But what is realistic is having an accidental misconfiguration of a generic all within the network, and then abusing that through maybe shadow credentials or just simply resetting the password of that computer account to then take over that computer, impersonate that object, and then performing resource-based constraint delegation to escalate yourself across the network. It's a lot more practical, and again, this is abusing what Active Directory normally does, right? So this is all misconfiguration issues, which is why this is still relevant in 2025. The best ways to audit resource-based constraint delegation attacks: do you have Bloodhound authorized within your network? I would recommend clicking on your object, on your user, and then looking at the outbound object control. See what kind of effects your user can do across the network. What can your user write to? What can it affect? What kind of control does it have externally? Additionally, if you don't have Bloodhound, another recommendation could just be using another tool such as maybe Bloodhound Enterprise or Ping Castle, anything that automates the process of looking through DACL controls within your environments, or even a simple PowerShell script could do the same effect. There was a tool that I've seen that Microsoft published that allows you to enumerate the different DACLs with a friendly GUI. I'll drop that link in the description as well in case you want to check that out. But definitely audit your DACLs, because this is definitely the first step in the privilege escalation across the network. That's it for this video. Thanks again for watching, and let me know what you think in the comments.